After my baseball making video, some of you asked for a tutorial, and here it is. I'll show you how to make the pitching system that I made. First thing is the setup of the baseball diamond. Second, we'll deal with making a character the pitcher. Third, we'll mess with this GUI and detecting where the player clicked. After that, we'll make wherever you click align with a real world position. And then the last thing we'll do is make the ball actually go from here to where you clicked. Okay, so I have my baseball diamond here. It's nothing difficult to make. Honestly, you don't really need this, but I think it looks nice as long as you have a place to pitch right here and a place for the pitch to go to, which is my home plate. And I know my home plate is a diamond, just it's okay though. Yeah, I just made this little simple thing. It's gonna look however, but we are going to need specific things here. First, let's make a ball, aka I just add a sphere, name it ball, make it white. And I like it leather. And how do we know what size to make it? Well, if you go to avatar, rig builder, and we'll do my avatar. Doesn't matter if you do R15 or R6. So then you can scale this down. Make it a good size so that it fits in the hand. That might be a little small. I can make it a little bigger. Yeah, something like that. Whoops, I had caps lock on. And on this ball, we're gonna have can collide, off, anchored, true. Now, above the pitcher's mound, I'm going to add parts. And what should we call this part? We'll name him pitcher parts. I like to make it neon. Ooh, neon brown. 0.75 transparency. I'll make it neon green. And I'll make it a little bigger. And again, can collide to false, anchored to true. And now we're going to need one final part. And this time it's going to be above the home plate. So I'm going to rotate like this. This is going to be the zone you're going to pitch to. So however big you want the area you pitch to be, I'll make it something like this. And if you want, you can use your character as a reference. Something like this is fine. And I'll make it a different color, okay, like a dark gray. And half transparency, and make sure anchored is true and can collide is off. Also, we're going to name this pitch zone because this is the zone you're going to pitch to. And now we don't need the rig for now. And this is the setup of how your diamond should be. The ball doesn't have to be here, but we'll leave it in workspace for simplicity. Now we're going to get into some scripting. Well, first what we're going to do is whenever somebody touches this pitcher part, they become the pitcher. So we're going to insert a script into server script service and delete this, and I'll organize it a little bit. Let me add some variables in here. All of my baseball diamond is inside of this group called field, so let's get a variable for that. Field equals workspace.field. Also, we're going to need the pitcher part. So local pitcher part is inside of the field and it's called pitcher parts. And we're going to use a touched event on this. So pitcher part touched hits. And if you don't know how events work or variables work, I have a video on just about every part I'm going to cover: events, remote events, local scripts, all that. I'll link them in the description if you need. So first we want to make sure whatever touched it is a character. So if hit dot parents find first child humanoid. So if whatever hit it is a character, then it will have a humanoid inside of it. We're going to need another variable. I'll call this pitcher chosen, and that's equal to false right now because we don't have a pitcher. But when somebody does touch this green part, then they will become the pitcher. So whenever the green part is touched, then we will have a pitcher. So, but I only want it to work if we don't have one yet. So if it does have a humanoid and we don't have a pitcher yet, then pitcher chosen is equal to true because we now have a pitcher. Whoever touched the part will become the pitcher. And this won't run anymore since we only let this run if we don't have a pitcher. Now we're going to make the pitcher part disappear. We don't need it after the pitcher's chosen, and we'll make some variables. So we know that whatever touched its parent is a character, and we know that it has a humanoid and that it's inside a character. Now we're going to use a method that models have, or groups, whatever they're called pivot to. And basically we just give it a C frame and it'll teleport that model to that C frame. So if we make it pitcher part dot C frame, it'll take the character and move it to the pitcher parts C frame. And also once you're there, we don't need you walking around, so let's set your walk speed equal to 0. And last thing we want to do, this is just in case you want to do more stuff with this character set attribute. We're going to give it an attribute, which is basically like a property that you make up. We'll call it role and we'll set that to pitcher. Now let's make sure this is working. When you touch it, it should teleport me here and reduce my walk speed to nothing and make my attributes of roll to picture. Yup, and I can't move, but it did face me the wrong way. We could easily fix this by changing the picture parts to rotate 180 degrees. And let's try it again and make sure it works. Yes, I'm facing the right way this time. Now what we want to happen is when you become the picture, a GUI to show up. Remember how I had at the beginning that I had a GUI where I could click where I wanted the ball to go? We need that to show up, and for that, we're going to need a remote event. We just put that remote event inside of replicated storage so that both the client and server can see it. First, we'll need to get that service. I'll call it RS for game, short for replicated storage. I know complex stuff here. And for the variable, for the remote event, we'll call it RE, set it equal to rs.remote event. Now what we want to do, we need to get the player. So we could easily get that, but first we need to get the player service. We set that equal to game, get service players. So local player equals p get player from character. So we give it the character and it'll give us the player. Now we can take the remote event and fire client. And the first argument is the player we want to fire. So whatever player touched it is whatever player we will fire. And I'll say show picture button here. That's the first argument. And if you don't know about remote events, like I said, I have a video on it, and I'll just add a little more organization here. Now we need to get into the local script to actually make the button appear and stuff. Well, actually, let's design the button first. Inside of Starter GUI, we're going to add a Screen GUI, and inside of that, we'll add an image button. First thing I'll do is make the anchor point 0.5. Basically what that means, by default, you control it by the top left. You move it 300 pixels to the right and 300 pixels down. It'll take the top left corner and move it 300 pixels to the right and 300 pixels down. If I change the anchor point to 0.5 for both axes, now all the movement is calculated from the middle. It's basing the size and position from the middle, since 0.5 is halfway across this way and halfway across up and down. So 0.5, 0.5. The position, I like using the scale for everything so it's more uniform for everyone. I'll change this to 0.75 and about 0.6 down. Even for the size, I don't use pixels. I use the scale. I don't use the offset. Let's make it 0.125 and about a quarter of the screen in the y-axis and no pixels. Let's make the image transparency 1. Unless you have a picture that you like, you can put it here. That'll go here. And for the color, background color, let's make it 50 in every axis. And also I'm gonna turn auto button color off because right now when you click it, it flashes and stuff. I don't want that. Also you'll notice if you change it, if you have a skinny phone like this, it'll make your box really skinny. And we don't want that, so we're gonna add some constraints to this. First, let's name it picture button. Now let's add a UI aspect ratio constraint so it keeps the same aspect ratio. Let's just keep a ratio of 0.75. That's about a good size to have it, right? Like ratio wise, it matches up close enough with the one I have here. It doesn't have to be perfect. And also a size constraint. So that would be a UI size constraint. And let's say we want the minimum size on the x-axis to be 75 pixels so it doesn't get too small. You see, if we shrink it down, it stops shrinking. So now you still have not a skinny box, even if you have a phone like this. Yeah, cool. And by default, we want this to be invisible. So let's turn visible off. And then when you become picture and that remote event triggers to you, then we want it to show up as visible. To do that, we're gonna need a local script. So we're gonna put that in starter player script right here. Not starter character script, although it won't matter that much. So on local scripts, I like to get the player right away. So we get the player service in local scripts. You can just get whatever player the script belongs to by doing players.local player. Also, we're going to need to access the remote event on the local script too, so we can just do the same thing we did over there, rs, to get the replicated storage. And of course, you can call your variables whatever you'd like. But this is just what I do. I don't know why I do it like this, but I do. And RE equals to rs.remote event. Now we can focus on when the server communicated with us through the remote event. And to get that, obviously we do on client event, connect function, And I like to call this event not to be confused with like, oh, scripting events. It's just like what event triggered this. And if you remember in the script, the first argument I wrote after player was show picture button. So that's going to be equal to the event. So if the event is equal to show picture button, then and I just do it like that. So like in case I want to use the same remote event to fire player for something else, like let's say I wanted to show a different GUI, I can use the same remote event and do like else if event is equal to show other button, then I can do that too with the same. I think it's simpler. I think that's the simplest way to do it. If you know a better way, let me know. So what we want to happen is when this is triggered, show the GUI we just made. But for that, we're going to need to get the player GUI. You might think you can just go into starter GUI and go into screen GUI and then get the picture button from there, but that's not how it works. These get copied into the player when a player joins, so we have to get the player's version, not the original version. But it's really easy to do that. Instead of screen GUI here, we just get the player GUI. And I like to do wait for child to play it safe with this. I don't know if I have to, but that's what I'm doing. You can do whatever you want. And basically instead of starter GUI, this is player GUI, and that's about the only difference. You can just move on from there. Pretend this is player GUI, and we can get the screen GUI from there. It's player GUI, wait for child, screen GUI, and then we can get the picture button that we made by waiting for the child picture button. And now that we have the picture button, we can check and picture button because we want to make sure it's actually loaded in first. Then and only then can we make visible equal to true. So if this works correctly, it'll transport us to the middle and show us the GUI we made. Perfect. Now our next step is to calculate the exact mouse's location on this rectangle. So since we made it into a button, we can do picture button dot activated, and I believe this will fire even if you're on mobile. But if you're on Roblox Studio, I know you have a laptop or desktop of some sort. I'll add a variable for the mouse equals player get mouse because we're going to need to know its location. We need to get the mouse's x position, x position, and we can do it like that, and the local y position. So I'm going to explain how we're going to get the position. So there's several ways to go about doing this. Let's pretend this big rectangle is the player screen and this smaller rectangle is the picture button. What we want to figure out, well, there's several ways to go about doing this, but I want to figure out the relative position from the left top corner of the button. I want to figure out where the mouse is in relation to the top left corner of our button that we made. So if it's right here, I want the position to be 0, 0. If it's here, I want it to be like 50% in the x-axis and 0% in the y because it hasn't gone down any. If it's over here, let's say it's about 3/4 in each axis, like let's say it's about 75 in this way and 75 down. I want it to be 75%, 75%, and so on, 100, 100 here, 100, 0 here, if that makes sense. So how do I get that? Remember, we're trying to find the distance from the top left corner of the button. Let's just stick to the x-axis. The problem is we want to know how far away the mouse is from the edge of the box. But when we get the mouse's position, it gives us the distance away from the edge of the screen. It gives us all of this, but we only care about this part right here. So how do we get this part? That's all we care about. Well, we have to subtract this part. And how do we get this part? We can get that part easily with a property called the absolute position. The absolute position tells us how far away it is from the edge of the screen in pixels on this side, and also the same for the y-axis. So we can do the mouse's position and subtract the button's position, and we get that yellow part that I told you we care about. So let's go ahead and get those variables that we need. We need the mouse's position and the button's position. So we already have the mouse's position. Now we need the picture button position in the x-axis goes picture button, and we have to use absolute position in the x because we use the scale, not the offset. So this will give us the pixels, both the x and the y-axis. And there's actually one more variable we need, and I'll show you why. Us as humans can look at this mouse and be like, yeah, that's probably like 75% of the way in the x-axis. But the computer, we have to be very specific with it because we only get this in pixels. Let's say that the yellow part is about 150 pixels. How do we know that 75%? 75% of what? Well, it's 75% of the whole square in the x-axis. Let's say it's about 200 pixels. Doing this calculation, the mouse's position minus button will give us the yellow part, which in this example we said was 150 pixels. To get to 75%, we then have to divide this by the size of the whole box, which is 200, and that'll give us the 75 we're looking for. We have to write this in code form and get all the variables we need. We'll make a variable for the picture's absolute size as well, called picture button size x, and set that equal to picture button absolute size x, and same for the y. So do you remember how to get the percent in the x-axis? First thing we do is take the mouse's position and subtract the purple part, aka the absolute button's position. So mouse position minus button position. We do that. Mouse position, so the x, mouse x, minus the picture position, which we named picture button pause x. And I'll put that in parentheses. And you remember the last step to getting the position is to divide by the whole length of the button in the axis that we're in. In this case, it's the x-axis. But it's the same for the y too. So this will give us the actual percent we're looking for. So divide by the button's x-axis size, which we called picture button size x. And again, I'll copy and paste this and change all the x's to y's. Now we can print to test it out x percent and print out the percent x and the y percent. Print out percent y and see if it's working how we think it should. It should give us the percent of how far away we are from the top left corner of the button. So if I click up here, it should be pretty close to 0, 0. Yeah, x percent close to 0, y percent close to 0. If I click here, it should be around 50% in the x-axis because I'm about halfway in through this button, and 0% in the y-axis because we haven't gone down at all. Yeah, 48%. And here should be about 75, 75 if I'm good at looking, 71 and 65. I'm terrible at looking apparently. And last test, just to make sure, this should be near 100, 100. 98 and 98. Perfect. So now we know that we're getting the distance away from the top left corner accurately. Now I'm going to fire to the server to let it know to throw the pitch. So fire server, I'll call it throw pitch, and we're going to pass on the percent x and the percent y. Now let's move back to the server script. Now we're going to have to detect for when the client has communicated. So the remote event, this time on server, because we're on the server script, function, player, and I like to do these as variable A, variable B, etc. For the same reason I said earlier, if I want to use this event for several other things, I can just repurpose these variables. In fact, I'll repurpose them right now. I'll show you. So this is for throwing pitch. If event is equal to, remember this isn't the first event I pass because when you're talking to the server, it always passes the player through first, and then whatever you set as your first argument next. I called it event here. I made it throw pitch. So if event is equal to throw pitch, and let's make sure that the player has a character, we can go ahead and we can now name it percent x equals to variable a because that's what we told it. We pass on the percent x and percent y here. So we know that the variable a is going to be percent x and percent y is going to be variable b. To make this pitch happen, we need to get some things. For example, the destination. So where exactly on this physical box in this pitch zone is the ball going to land? We have to take the percent, let's say 25%, and convert that into a real Roblox position. To do that, we're going to need a few things. So first, let's make a variable for the pitch zone. Mine is in the field. Remember, pitch zone is this area here. And we're going to need a few variables. For example, we're going to need that zone's position in the x-axis and also in the y position. And same with the size, we're going to need the x and y of the size of the zone. And here, I'm going to take a break from this to make a little part real quick. And I'm going to name this part marker because it's going to help us mark where things should go. And I'll make it semi-transparent. For size, I'll make it 2 by 2 by 2. And I'll make it not can collide and anchored equal to true. And I'll add a variable for it at the top right here, even though we're not going to use it very long. equals workspace.marker. This will just help us verify that things are in place. Okay, so this is the pitch zone, right? How do we get the position of the top left corner so that it matches up with our calculation of the percent that we did earlier on the GUI? We want to get the position of the top left corner of the pitch zone. When we did the calculations of the percent on the GUI, we did it based on the top left corner of it. But this time we're going to need the top left corner of the pitch zone, which is the physical vector 3 location. How do we get the top left corner if Roblox bases position based on the middle? Well, it's easy. We take the position and we subtract half of the size. So let's say we're on the x-axis. This is 0, this is the origin, 10, 20, 30, 40. So this square's position is at 30. We take the position and we subtract the size divided by 2, which is known as half the size, or times 0.5. And that'll give us this left edge. If we do it on the y-axis too, see how this is half the size? We'll end up in the top left corner right here. So remember, we got to get the position and subtract the size divided by 2. So local start x, remember, start x equals the position, and we take away the zone size divided by 2. We take away half the size. And again, same for the y-axis. And this is where the marker comes in. I want to make the marker's position equal to vector3.new start x, start y. And I guess I'll make a variable for the zone's position in the z-axis. But we're not going to use the c-axis at all since we don't really care. We'll just do the middle here. We don't really care where the ball lands thickness-wise. We just care where it lands here, like in real baseball. And we'll do zone position here. So this marker should move to the top left corner if we did this correctly. So let's test this out. And it's not moving to the top left corner. That means something is wrong. And if this happens to you, I'll tell you what it is. If you click on your pitch zone, you'll see that the size in the x-axis is 1. So if you're having trouble with the marker not going to the right position, that's because you need to rotate and resize your shape. Instead of 1 in the x-axis, we want it to be wide. And we want the z-axis to be the one that's thin. Now it'll match up with our x and y axis that we made. And remember, the marker should move to the top left corner and move to the bottom right corner. And I'll tell you why. You see, in this example, the number line is increasing as it goes to the right, but in Roblox, it could be backwards. So I could just rotate my whole field and it might fix it. But the problem with just rotating the whole field is that the y-axis is still backwards. So in Roblox, the higher you go, the higher the number is, right? So instead of subtracting to get higher, we have to add to get higher. And instead of subtracting to go left, we have to add to get left. That's why it was at the opposite corner, because we're doing the opposite operation that we need. So instead of subtracting half the size, we need to add half the size in this case. And it might be different for you. You might only do it for the y-axis, or just rotate your field if you want it to be like mine. And now it moves to the top left corner. Perfect. Alright, I have a math problem for you guys. Let's say that our pitch zone is 8 studs in the x-axis. And let's say our mouse is right over here at 75% of the x-axis this way. How many studs is that away from the left corner up here? What is this distance in studs? Well, the answer is really simple. You just have to do 8 times 75%, and that'll give you 6 studs. And that's what we need to find out the destination in the x-axis and the y-axis. So we got to do our percent times the size of the zone, and that'll give us the studs in whatever axis we're in. But remember, we can't just say 6 studs. We have to add whatever position our zone starts at up here. So we start at the start and then add 6 studs, because 0 could be all the way over here. So we have to start at the start and add 6 studs from there. So first we start at the start, and then we do our calculation of the percent times the width of the pitch zone in that axis. And this is what that looks like. So the destination, the x-axis, is equal to the start. And here I added, but since it's backwards, we have to subtract. So minus the zone's width times the percent x. And you guessed it, we have to do the same in the y-axis. And again, let's test with the marker, make the position equal to vector3.new destination x, destination y, and zone position z. This time the marker should move to wherever we clicked. There you go. See, it's moving everywhere that we click. Perfect. So we got the destination, and we know the start's going to be wherever the character is. So what do we do now? What do we need now? Now we need the physics calculation for the in-between part. And for that, we're going to need a service called run service. Not to be confused with the RS up here. I named this one run S. Game get service, run service. And I'm animating on this on the server for simplicity's sake. I know it's better to do things visually on the client, but this tutorial is long enough as is. And plus, this is how I did it for my video, I'm pretty sure. If you don't know physics, don't worry, we'll go through it together. If you look up kinematics equations, you'll find this one, and that's what we're going to be using. And if you know nothing about physics, I'll explain it to you. X is your position. If you think about it, when we talk about moving the ball, we're just changing the ball's position. As the time changes, we're changing the position. And this triangle means change in X. So where's our X changing in our baseball case? It's changing from the start to the end. And let's say we have a number line here. I know another number line, just bear with me. Again, counting by tens. And we have a baseball starting at 10, and we shoot it, and it ends at 30. What is the change in position for that ball? Well, it moved 20 stud. And how do we get that? Well, that's just 30 minus 10 to get the distance that the baseball moved. And that's where we get our 20 from. Well, we can just look at it and know 10, 20, that's 20. But this is really what we're doing. So when you see a change in X, it just means the destination minus the starting point. And that's equal to the velocity, but it has a little I right here. That just means initial velocity. So imagine a pitcher pitching a baseball. He's done. After that baseball leaves his arm, there's nothing he can do to add force to it. It's done. So he adds an initial velocity to that baseball, and that's it. And it's multiplied by t, which is time. And you know what time is. So let's say time is equal to 0, then the ball will be at the start, because if no time has passed, it's going to be at the start. And we're going to decide how long our baseball takes to reach the destination. And then plus 1/2 times a, which is the acceleration. And on Earth, the standard is, I think the speed gravity pulls things down is like 9.8 meters per second. And we'll include that in our script so our ball can have a nice curve like in real life. Times the time again, squared. So first, I'll show you which variables we're going to be controlling. We already got the destination, which is what we were doing with the marker just now. And we're going to get the starts, and also we're going to be keeping track of the time, and we're going to decide how long it's going to take to reach the destination both times. I already told you the acceleration is going to be 9.8, but we can change it to whatever we want, honestly, to simulate like wind maybe, I don't know. So as you can see, that's about everything. 0.5 is just a constant, except velocity. We'll get to velocity in a second. Let's get to all these variables that we need first though. First, let's make a variable for the character that threw the ball. So in this case, local dot character, and then I'll just do the humanoid root part of the character. For now, we can change this later. And the starting position will be that humanoid root part's position. For now, again, I'll change this later. Let's just make a local destination position. Go to vector3.new, destination x, destination y, and the zone pos in the z-axis. Again, it doesn't matter how far back the ball goes. So we have the destination, we have the start. What else do we need? We need a time. We'll call it duration. Let's say I want it to last 1.5 seconds to reach the pitching zone. And also we need the acceleration, which I told you normally is 9.8. but since we're dragging the ball down to the ground with the gravity, going to be negative. And also we're gonna have to need this velocity. But how do we get that velocity? Let's say I had a random equation like y equals 5x plus 10. I needed to know what x was equal to. How would you go about getting that? You have to isolate the x, get the x by itself. And you do that by subtracting 10 on both sides. We're left with y minus 10 equals 5x. And you subtract all that by 5, and you're left with x equals y minus 10 divided by 5. I mean, you can simplify this to whatever. So you see how you get to know what the x equals, and you got the x by itself. That's what we're going to be doing, the v. And honestly, it looks a little more complicated than this, but it's just about the same difficulty. It's really simple. Like we did before, remember we want to get the v by itself. We did before, we're going to subtract all of this on both sides, and that'll leave us with change in x minus 1 half at squared. I'll put this in parentheses. Equal to the velocity. I don't need the I. There's only one type of velocity here. You know what it is. Times time. And I'll flip-flop this. We're going to have the velocity on the left. So now we're going to divide by the time. Divide by the time. We're left with v equals change in x minus all this stuff. 1 half times time squared over t. And remember that change in x is equal to the destination minus the start. Then all of this is the same. All over time. So since we already have the time at the end, the acceleration we're going to have at the end, and all that, we can just put this into a Roblox form, have it figure out what the velocity will be. So velocity equals destination minus the start times 1 half times the acceleration times duration squared, all divided by the duration. So destination minus start is the first part, which we called destination pause minus start pause. And all that's minus 1 half. You can do 1 divided by 2, as long as you keep that in parentheses, but 1 half is easier for me. The acceleration times the duration squared, and all of this I'm going to put in parentheses because we're going to divide it by the time, which we called duration. Now I'm going to make a blank variable called trajectory, and we're going to set trajectory equal to run s. Remember, that's run service. Heartbeat, connect, function, delta. And if you don't know what this does, is it runs, it runs every frame. And the delta will tell us how much time has passed since the last frame. So I'm actually going to need another variable for the time passed. And right now at the start, no time has passed. And every single frame, we're going to update the time passed plus equals. That means it's going to add it to itself, delta. So first it'll be 0 seconds, and then when this runs, let's say 0.1 second has passed, then the time pass will be 0.1 second. So every time this runs, the time pass will get updated, the physics equation. And we're going to be using that physics equation. And now that we have everything we need, now we can use that original physics equation that we had at the start, since we have the velocity, we have the time. Well, we're going to have the time update every frame, and we have the acceleration. And that's going to affect the change in x, which is, remember, is the ball's position, which is what we wanted to change this whole time. So as the time will change, the ball's position will change. Remember, something changes over here, something will change over here. That's how equations work. So as we change the time, which will be updated every frame, the position will change according to this kinematics equation. So we'll memorize this real quick because we're going to put it in. Only difference is we have to add a starting position. So new pause equals, we're going to start at the starting position, and then we could do the kinematics equation. Plus the velocity times time passed. You don't need parentheses, but I like to have them. And we're going to add 1 half of the acceleration and the time passed squared. Great, so this will give us the new position we need. But when we're ready to throw the pitch, we should get a new ball. So I'll delete this. And in the variables, we don't need the marker anymore. So I'll just ball equals workspace dot ball. Down here in our events, in our if statement, we can get a new ball called ball equals ball clone, and set the parent equal to workspace. And now this new ball that we clone, we're going to set the ball's position to that new position. And why did I make an empty variable here and then assign it to here? Well, that way we can disconnect from within. And if you don't know what that means, is that this will stop running if I do something like if not ball, like if the ball doesn't exist anymore, or time passed has gone more than, let's say, 15 seconds, then trajectory disconnect. When we get this starting position, let's set the ball's position to that starting position. And let's test it out and see if it's working. If you don't know, the humanoid group part's in the middle of your character. And let's say we want the ball over here. I got carried away with the pause. Humanoid group part, top position. My bad. Now let's try it again. See, the ball's gliding beautifully. Let's see if I do top left corner. Nice. Bottom right corner. Middle. Great. And I can spam it. Nice. Let's take a break from this code real quick to add an attachment and clone it. Move one up slightly. Wait, what size is this ball? What's half of 0.75? It's like 0.375? Something like that. So I'll move this attachment up. That seems too high though. Whatever. And we'll set this attachment at the bottom. We're gonna add a trail. And attachment 0, attachment 1 will be the other one. And for size, where's the, oh here, width scale. At the start, I want it to be big, and as the longer it goes, I want it to get smaller. Let's see how that looks. Also, let's experiment with the duration. Let's make it take half a second to get there, so it'll have less of an arch. See, it'll take half a second, and I like the trail a lot. Nice. Get it from another angle. Nice. And also, just to make sure I did this correctly, let's make this pitch zone something crazy like that. I like to do a lot of testing. And top left corner, yup, still goes right through. The top left corner, the middle, bottom right corner, yup. You can make your zone as big as you want. Alright, so everything's working well, but it's kind of ugly. So let's make an animation. To make an animation, just go to Avatar, Rig Builder. What is this game? I forget what it is. If you don't know if your game is R6 or R15, go to Game Settings, Avatar. And here you can see mine's R6. So I'll bring in an R6 rig. And from here, you can go to Animation Editor, click it, and you can move your character along the time. For example, at the start, I'll look like this. I'll have my arm back here or whatever. And then at the 0.4 second mark, I want my arm to go like this. Then it'll look like this. It's really simple to learn animating, and you can make it like 5 seconds long if you want. And make it 3 seconds to do that motion. But I already did an animation for my video, so I'm not going over it. And this isn't an animation tutorial. Like, it's really self-explanatory. And there's lots of tutorials out there if you need one. I'm just going to use mine. Let's pretend you have an animation moving forward. So if you want to pause, make an animation, come back. I'll be here waiting for you. Don't worry. Let's make a variable called pitch track. Set that equal to nothing. Or you can just do like this if you're cool. But I'm not feeling that cool today, actually. And in the local script, remember this is the local script right now. I don't know if I mentioned that. But to deal with animations, we're going to do that in the local script. I'm going to do a function for when the character is added. And this function, I'm going to call on character added. And it's going to take a parameter of character. And we'll say local humanoid is equal to character width for child humanoid, and a local animator is equal to humanoid wait for child animator, and a local animation, we're going to make it an instance.new animation. We don't need to give it a parent. It'll work just fine like this. And that animation, we're going to set the animation ID equal to the whatever ID of your animation is. I'm pretty sure you can just write the number in here as a string, but I'll write out the whole thing. Go ahead and copy and paste the ID of your animation in there. And make sure your priority on your animation is high enough that it'll actually play. Pitch track. Now we can set pitch track equals to animator, load, animation. I'm pretty sure there's a way better way to play animations than waiting for the character to be added and loading it in there like this. If you know of a better way, let me know, because I really don't know. And now we'll set it equal to the event of when the character is added. We're going to connect that event to that function. Now whenever the character is added, it'll play this function and load in the animation into the humanoid. However, if the player character is already added, then this will never run because this only runs when the character is added. So if the character is already there, then we want to make sure we play our animation anyways. And this time we do have to pass on the argument of the character. So now when we click the button, I'll make a comment here for pitch or button clicked. Now, if there is a pitch track, if it has loaded into the character, then pitch track play. Let's see. Perfect. It plays the animation. I really like this animation. I said that in the other video, but I really do. Now with the animation, I don't really like the spamming because it'll get like glitchy with the animation. So let's add a pitch cooldown. Pitch cooldown, we'll say 3 seconds. Local can pitch equal true. At the start you can pitch because you're not waiting for the cooldown to be over or anything like that. And we'll encase all this in an if statement. So if you can pitch, then and only then can you do it. All the pitching stuff we wrote in here. So if can pitch, then can pitch is equal to false until we wait for the pitch cooldown, however long that may be. I made mine 3 seconds. You can make yours whatever you want. Then you can pitch, again, can pitch equals true. And I like to select everything, Control A, Control C, Control V, and it'll indent it beautifully for you. Also, you can just, there's a way to do it, but I'm too lazy to remember. Oh, format selection. Format selection. Yeah. And congratulations, you're done with the local script. You can close out of that. But let's go ahead and test everything like we always should. Emphasis on should. So I pitch, and I can't pitch again until the time is over. Oh, I never set the time back to 1.5, but it's fine. Let's make it iteration 1 just to be different. If you notice, the ball leaves way too early than it should, and it comes from my torso, so we're gonna fix those issues right now. So right here, if the player.character and player.character find first child, I'm in R6, so for me it's gonna be right arm. If you're in R15, it'll be right hand, like all together, not spaced. So right after here, I'll do right arm, local right arm equals player dot character find first child right space arm, and I'll do local ball start position equal to right arm dot position plus right arm dot c frame dot up vector times -1. If you don't know what this does, I'm gonna need that rig again. The midpoint of the arm's position is about right here, and the up vector is this way, but we want it one stud down so that the ball is going to be like in the palm of the hand. If you're an R15, you can probably just do it right on the hand. Maybe you'll have to tinker with the up vector or look vector or right vector a little bit to get it perfectly how you'd like. Anyways, the ball will be moved to ball dot position equal to ball start position, and we can delete this one. And once the ball is there, we're going to set the anchor to false because we're going to weld this ball to the hand for a little bit. And we'll do that with the weld constraints. Ball, not a weld constraint, since we already positioned the ball where we want it. And weld dot part 0 equals the right arm. Weld dot part 1 equals ball. And remember how I told you the ball goes too early? So we're going to have to wait. Task.wait. Mine's going to take about 0.65 seconds, but you might have to do some trial and error to get yours to release the ball exactly when you'd like. So we pitch, we're doing our pitching motion. After 0.65 seconds, he's ready to release the ball. So we get the starting position is going to be equal to whatever the ball's position is at that given time. That's where the ball's going to start, wherever the ball is. Shocker, I know. And now we don't want the ball to be unanchored anymore. So we're going to anchor it and destroy the weld. Also, one more service. I'm going to be adding local d equals game get service debris. And after, let's say, I don't know, after the 60 seconds of the ball, if the ball still exists, we're gonna delete it. You know, we don't need more trash in the game. And let's see how this works. Nice. Yeah, this is what I wanted. The trail looks kind of goofy at the start, so ball, trail, enable, you can set that equal to false. And then after he lets go, we can do ball dot trail and enable equal to true. We only see the nice arch. And obviously you can tinker around with all these settings, like make the pitch cool down 1, or even crazy stuff. Watch this crazy stuff. Math.random, say 5 to 75 divided by 10. You can tinker with the gravity and stuff. Oh yeah, so if you can tinker around with all these settings, like make it like this, or make the acceleration like in the weird axis. I don't know, man. Yeah, and if this video does well, I'll do one on the batting as well. If that interests you, let me know. I hope you enjoyed and check out my group in the description. Why is my head like this? What? Do I always have the man hat? Anyways, I was just messing around and I just want to show you this. I made the acceleration 100 in the z-axis, and it kind of emulates wind a little bit. And look, to actually get to where I want it, he has to throw it backwards because the acceleration, you know, to actually get there in the 2 second time I put, he actually has to throw it backwards. I thought that was pretty cool. Now if I make it negative, look at this. He has to throw it behind. It has to come in from behind. It still reaches the destination in the 2 seconds, but just in a crazy way. So yeah, experiment with this. Let me know if you have some cool stuff with this.